Algebra 2 kids, this is Dr. Callahan with week 9 of Friday. So you guys made it, yay, congratulations. This is your warm-up log, so go ahead and pause the video and answer any of the 3 questions right here. I know that it is not quite 3.14 or March 14th, but we actually start celebrating Pi Day literally a week or 2 weeks ahead of time. And so with that said, let's go ahead and get started with today's stuff. Your warm-up log is due today. So what you need to do is make sure you have your warm-up log out and you need to start counting the boxes. We're going to be filling out these 3 things and they're all going to be worth 100 a piece. So in a few words, think about how many different boxes have you completed. So you should have about 100. If you have over 100, that's totally fine, and you'll get extra credit for that. Second thing you need to think about is your participation. So when it comes to your participation, where do you think you did in the last 9 weeks for this class? Specifically, you can't be tardy or absent. You can't really participate if you're physically not here. Do you complete the assignment in class? Do you do the exit ticket that's on Google Doc? Do you respond to the question and the reflections on Padlet? Things of that nature. Do you turn in your assignments in my class when it is due? So that is for your participation. It's out of 100. Next is your preparation. Are you essentially prepared for class? As in, do you have your cell phones off, electronics away? Is your pencil and paper ready? Do you have your materials ready to go for class? So then all together, it is going to be about 300 points, and you are going to document this on this QR code or this form right here. So if you can go ahead and access this with your QR code, I know if you're using your cell phone, you might want to grab an iPad off my desk, and then that way you can go ahead and access this. And this is for week 1 to 9 for period 3, semester 2. Okay, so once you get to that form, this is kind of what it looks like, and I'm going to show it to you guys briefly. This is what it looks like. You need to put your first and last name and the period, answer the following questions, and then keep going, and then lastly, just submit. And that's all that you have. Okay, so last class we went over was the maze. So if you were in class with me, this is what we completed. If you were not in class, make sure you grab this worksheet and then complete it and then turn it in. Your Math Excel for your assessment and also your homework is available. This is what it looks like on your Math Excel for week 9. You have 2 assignments. It is due by Sunday by 11 p.m. In addition to that, I do have after school tutoring if you need additional assistance. This is your YouTube channel for this class. Obviously, if you're accessing today's video for week 9 Friday, you have access to it. There are 41 videos, and every single thing that we've done in class is included, including yesterday, which is week 9 Thursday. And so if you have missed anything, make sure you guys go ahead and watch that. Okay, so today we're still on radicals, and so this is going to be our topic. So first thing I'm going to have you guys do is make sure you grab the handout. It's on Pi Day. It's a pattern grid. So you're going to need color pencils and then also a ruler for today. And the reason why we celebrate Pi Day, it's really a special day in the lives of many nerds, just like Valentine's Day or National Pancakes Day, if you can believe that we have one. But it's celebrated on March 14th, which is coming up. And so today, to celebrate part of Pi Day, if you don't know what it is basically the circumference of the area of the circle in relations or the ratio of the area to the circumference of a circle. And there is really no patterns as to how this works. It just starts at 3.14 and it just keeps on going forever and ever and ever. And if you can imagine, how would anybody be able to memorize this? Well, guess what? Back in 2000, Daniel Tammet actually was the guy. He holds the world record for being able to memorize 22,514 digits of pi after 3.14. And currently he has the world record for that. And he did this back in 2004. So good for him. All right, so I have a few little jokes. What do you get when you cut a jack-o'-lantern by its diameter? a pumpkin pie, haha. Next one, what do you get when you take the sun and divides its circumference by the diameter? A pie in the sky. And then last one, what is the official name of Pi Day? It is a python, duh. So now what you're gonna do is you're gonna take the handout that you grabbed from me, you're gonna have a ruler and then also color pencils. And then what you're gonna do is you are gonna title your paper, Pi Inspired Art, and then write down your name. You're gonna draw 10 different dots around the paper, making a decagon, which is a 10-sided polygon. I've actually already did this for you, so that way it's already organized. You're gonna use one color for each dot, and you're gonna start with 3 dots, and then connect it to 1, then connect it to 4, and I hope you see the pattern because it's 3.14, and then continuing on, it'll be back to 1, 5, 9, 2, 6, 5, 3. So essentially, when you're done with everything here, you will make something that looks like this, okay? And so if this is what I have, I'm gonna go ahead and start off with this color is, whoops. We're gonna say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're gonna have 10 different colors. So I'm gonna have this one be blue, this one be dark blue, this one will be orange, this one will be purple, this one will be green. And your colors will vary because you'll have more color pencils than I would. And then I have red, I have dark red, black, and let's do maybe yellow. I think that will be a good choice. And here's yellow, okay? So I'm gonna start off with 3. So with my orange right here, I'm gonna do 3, then to 1. So from here with your ruler, you're gonna take 3, connect it to 1. So 1 is now light blue. Then from 1, you're gonna go to 4. So 1 to 4. So use your ruler. And then from 4, which is gonna be a dark blue, I'm gonna go to back to 1. So here we go, back to 1. And then from 1, I'm gonna go to 5, which is going to be over here. 5 is now green. So I'm gonna take green, I'm gonna go down to 9. So all the way over here. And then from 9, which is black, I'm gonna go over to 2. So from 9 to 2. And then from 2, which is a dark blue, I'm gonna go to 6. And then from 6, which is a light green, I'm gonna go to 5. And then from 5, which is a dark green, I'm gonna go to 3. And you guys get the gist of it. So you're gonna keep on going back and forth until you're done with the entirety right here. And that's what you're gonna be working on. So pause the video and go ahead and work on this for the next 15 minutes, okay? And make sure you guys time yourself. Okay, so your 15 minutes is up. I know that was kind of quick. So you should be done with all of these digits, and at the very end, you should have this beautiful like dream catcher diagram looking thing. So make sure you have that done. Okay. All right, next what you need to do is flip your paper over to the back and you should have this. Now what this is doing is we're gonna go over a few expressions when it comes to exponents. And so let's take a look at number 1. So for number 1, you have a 3 right here. And what you're gonna do is you're gonna go ahead and distribute that. So you have a to the 6 because it's 2 times 3, b to the negative 9. Now you can't have a negative exponent, so we're going to move that up. So you have a to the 6, b to the 9, and that is your first answer. So fill that part out. For number 2, you have the same thing. 2 times 5 is negative y to the positive 10th power, y squared. This one is a negative, so you're going to bring it down to the bottom. And so then when you have a y times a y, you add the top. 10 plus the 2 is going to give me a 12 over y to the 12th power. Well, guess what? It's the same one top and bottom. So really, you just have a negative 1. And that is what's left. For number 3, you have 12 over 16. So we're going to reduce this. So to reduce it, we're going to reduce it by 4 top and bottom. So then you have a 3 and a 4. We're going to slide that 1 on top. So you have an x squared. Slide that 2 down because you always want to move the smaller of the numbers, especially if they have the same y. So that's going to be a 3. Slide the 1 down. So it's z squared. Okay, number 4. So we're going to do the same thing. Which one's a smaller number? That 1. So add the 1 by sliding on top. Which one's a smaller number? The -2. So slide it up. So you have x to the 6, y to the 6th power. Next, what we have is we have this one here. So we're going to take that 3, distribute it in. So we have rs squared over r to the 3rd, s to the -3rd. And then once we distribute it, we're just going to slide these numbers around. So that 1 becomes a -1. This 3 becomes a +3. So then I have r stays on the bottom. 3 minus 1 is a 2. When I slide it up, s stays on top. 2 plus 3 is a 5. And this is my answer right there for number 5. For number 6, you have a negative. We don't want that. So we're going to bring that entire thing down to the denominator. So you have a -2, x to the 5th, y to the 3rd, and it becomes a positive square. Then you have to distribute this to these individual ones right here. So you have a -2 squared. 5 times 2 is a 10. 3 times 2 is a 6. And if you go ahead and multiply it out, 2 times 2 is a -4. X to the 10, y to the 6. And that is your answer for number 6. For number 7, so let's take a look. You have an x and an x squared, which is x to the 3rd, 4 y to the 3rd. You cannot, oh, actually, I'm sorry, you have 1 y right here. So I'm going to bring it down. So -1, that's a square. So if I reduce 2 over 4, it's 1 over 2, x to the 3rd, y squared. And this is your answer. Okay, so for number 8, what we're going to do is we have a lot of negatives. I see this negative, so I'm going to move that down. I see this is a negative, I'm going to move that y up. So we just have to kind of like organize this first before I start canceling anything. So -2x squared goes on top, the y goes up, so you have that y right there. On the bottom, you have 3x, but remember if you move that 1 down, it's 1 plus 1, which is a 2 squared, y to the 3rd. Then once I have everything shifted, notice that these two are exactly the same, so the x's cancel. If you move your 1 down, you subtract it, so -2 over 3. 3 minus 1 is a 2, so this is your answer for number 8. Okay, so for number 9, first thing I want to do is I want to distribute that square to everything here. So then I'll have 3 squared, which is a 9. 2 times 2 is a 4. 5 times 2 is a 10. 1 times 2 is a 2. Same thing here. 2 squared is a 4. 3 times 2 is a 6. And once I have this, I'm going to move that 4 down because that's a smaller one. So then I will just have 9 y to the 10, z squared, 4 stays on the bottom, and then x squared. And this is my answer. So for number 10, given the fact that this is a negative, to make it a positive, I just have to flip this. So you have 2x to the 4th, x to the 3rd, y squared, and then that -2 becomes a +2. Once you have that, you're going to take that and then distribute it inside. So then you have 2 squared x, 4 times 2 is 8. 3 times 2 is 6. 2 times 2 is 4. Then you're going to move that 6 up because that's a smaller exponent. 2 squared is a 4. How many x's do you have on top? 8 minus 6 is a 2. Y to the 4th stays on the bottom. All right, you guys, this is pretty much the end of your lesson. We'll talk more about this next time. But if you are done with this, make sure you do finish your plot out pie inspired art. Make sure you put your name on this. And as always, I hope you guys have a wonderful day, and I'll see you guys next time. Take care.